Along coastlines all over the world, a crisis is quietly unfolding. Rising seas, bigger storms, these aren't some far-off threat anymore. But what if the very maps we use to protect ourselves, the ones that tell us where to build our homes, our schools, our hospitals, what if they're fundamentally wrong? What if we're navigating this entire crisis completely blind?
For generations, communities all along Kerala's 590-kilometer coast have lived with the rhythm of the sea. In villages from Alappuzha to Kasaragod, climate change isn't some abstract computer model. No, it's the water seeping into their walls. It's the shoreline that's been their identity, just disappearing overnight. For them, it is a lived daily reality. And yet, for decades, the official response has been to rely on these old, static maps. You know the kind. They draw these neat, clean lines, high risk here, medium risk there. It offers this dangerous illusion of certainty in a world that has, frankly, stopped playing by the old rules. Trying to plan with these maps, it's like trying to navigate a hurricane with a photograph of a calm, sunny day. And here's the really crucial point. When we actually factor in the deep uncertainty that comes with climate change, these traditional maps don't just get it a little wrong, they get it profoundly wrong. In fact, nearly 30% of Kerala's coastline is misclassified. Just think about that for a second. That's almost a third of its communities, homes, and hospitals being told they're safe when they might not be at all. So you see, this isn't just some small mapping error. It's a systemic failure. We are, quite literally, flying blind, and we're relying on this completely outdated understanding of risk that is leaving millions of people dangerously exposed.
The old approach has a name. It's called deterministic mapping. It basically takes a few variables, crunches them, and spits out a single confident answer. But here's the problem. It completely ignores the wild, unpredictable nature of climate change. It pretends hazards exist in a vacuum, when in reality, they collide, they amplify each other. It gives us a false sense of precision in what is a deeply, deeply uncertain world.
To see the coast clearly, we realized we needed a complete revolution in how we map risk. We had to move away from that single static picture and build something new. A dynamic atlas, one that actually embraces uncertainty instead of trying to ignore it. Our new framework attacks this problem in 3 connected steps. First, we use an ecological lens, a model called INVEST, to map not just the physical threats, but also the natural defenses, things like mangroves. Then, we feed all of that data into an explainable AI. This is key because it doesn't just tell us where the risk is, but more importantly, why. Finally, we run thousands of possible futures through a probabilistic simulation. The result isn't one map. It's a living, breathing atlas of risk. And you know what? The AI revealed something fascinating. It found that the single biggest driver of physical risk isn't just wave energy, which is what we've traditionally focused on. Not at all. As you can see here, wind exposure accounts for almost half of the risk. And the shape of the land, the topographic relief, that comes in second. This discovery completely changes where we should be looking for danger. So, with this new scientific lens, what does the true landscape of vulnerability in Kerala actually look like? Well, the results are both startling and incredibly nuanced. Our new atlas reveals 2 totally distinct types of danger zones. First, you have what we call persistent hotspots. Think of places like Kasaragod and Alappuzha. These areas are high risk in almost every single future we simulate. They need immediate protection. But then there are the emergent hotspots, places like Thiruvennan's Purana. These are the tricky ones. They look safe on the old maps, but they flicker into the red zone when you factor in uncertainty. And these hidden risks, they require a completely different strategy, adaptive management. But physical hazards are only half the story. Because, at its core, risk is a social equation. The danger isn't just about how high the waves get. It's also about a community's capacity to withstand the storm when it hits. Let's take a look at the district of Malappuram. If you only look at the physical side of things, as this chart shows, its exposure to hazards is just moderate. But when we start to measure its social vulnerability, we're talking about things like poverty, population density, how much people depend on fishing, the picture changes dramatically. That very high social vulnerability, it acts like a risk multiplier. It takes Malappuram from a place of moderate concern and elevates it to one of the highest risk districts in the entire state. This is exactly the kind of critical insight that the old physically focused models completely miss. And here's the thing, this risk isn't just rising steadily, it's accelerating. Our projections show a moderate increase by 2030, a really significant jump by 2050, and then a dramatic surge toward the end of the century. This acceleration means that waiting around to act, it just isn't an option.
So a clearer understanding of risk demands a smarter strategy. How does all this new science translate into real action? Well, it gives us a clear three-tier plan for building a truly resilient coast. We propose a straightforward three-tiered response. For Tier 1, those persistent hotspots like Kasaragod, the key action is to protect. We do that with a mix of smart infrastructure and solutions that work with nature. For Tier 2, the uncertainty zones like Thiruvananthapuram, we need to manage the risk. That means careful monitoring and flexible, adaptive plans. And for Tier 3, the socially vulnerable areas like Malappuram, we have to strengthen them. That's about diversifying livelihoods and building stronger social safety nets.
Now, turning this into reality requires a mandate for change. In the short term, policymakers have to embed uncertainty into all their risk assessments. It needs to be step one. Strategically, over the next decade, funding must prioritize areas with the highest composite risk, where physical and social vulnerability collide. And systemically, for the long term, these new probabilistic ways of thinking have to become the absolute standard for all planning.
You see, Kerala's coast is really a microcosm of a global challenge, and its story offers a blueprint for vulnerable regions everywhere. The core lessons are pretty clear. 1. Uncertainty isn't a bug in the system. It is the system. 2. This new scientific framework can be adapted and used worldwide. And 3. Truly effective, equitable adaptation has to integrate the social dimension of risk.
Ultimately, what this all calls for is a really profound philosophical shift. To plan for a single, so-called most likely future is to guarantee that you will be unprepared for the future that actually arrives.
The maps of the past gave us false certainty. This new atlas gives us something far more valuable. It gives us clarity. The clarity to see risk in all its dimensions, and with that, the confidence to act. The question now isn't whether we can see the future anymore. The question is, are we finally ready to embrace an uncertain one?